Okay, in this heat capacity and specific capacity lesson, we are going to learn this particular formula Q equals to mc theta. So these are learning objectives. Just a bit of recap, specific capacity is the amount of thermal energy required to change the temperature of 1 kilogram of material by 1 degree Celsius. So if taking for example, specific capacity of water is 4,200 joules per kilogram per degree Celsius. It means that if we want to change 1 kilogram of water by 1 degree Celsius, we require 4,200 joules of energy. So by extension, 1 kilogram specific capacity of water 4200 changed by 1 degrees require 4002. 2 kilogram will require double, 3 kilogram will require triple, and 4 kilogram would be require 4 times of the energy required. So if you just only want to change by 1 degrees but you have different mass, you just multiply accordingly. It's just only 1 kilogram of water, but I want to change the temperature by a larger change in temperature. So change by 1 degrees is 4002. Similarly, if you change by 2 degrees, it's 8004, 3 degrees, 12,006, and 4 degrees, 16,008. So again, it's quite similar, but this time around, your mass is all standardized 1 kilogram, but change your temperature by this. So what if you want to change, say, 3 kilograms by 4 degrees Celsius? How much energy do we need? Okay, do a quick calculation. If you are not able to do that, the answer is 50,400. Okay, how are we able to do that? It's actually you can approach by having 3 kilogram, 4,002 and 1 degrees is 12,600. But this same 3 kilogram, you want to change by 4, you have to multiply by 4. So you find that it is 50,400. Or if you just only want to do in one step, you just multiply 3 times 4,002 times 4. And you get 50,400. So the general formula for the thermal energy required is just mass times specific capacity times the change in temperature. Okay, you can write in this form. So this Q equals to mc theta. Where Q is the energy required for the change, m is the mass of the object we are talking about, c is the specific capacity of the material, and this theta is the change in temperature. So please remember that it's change in temperature and not the initial nor the final temperature of the object. Sometimes you can make less mistake by if you replace this delta by this difference in terms of temperature of a higher where theta H is the higher temperature and theta L is the lower temperature. So if you subtract them, of course, would be the change in temperature. So an example, what is the energy required to heat up 5 kg of water from 25 degrees to 90 degrees, given that specific capacity of water is 4,002? So what you need to do is just to apply the formula. So we want to find the required energy, and you just substitute in mass times specific capacity times the higher temperature 90 and the lower temperature 25, and you get this 1,365,000 joules. Some example of incorrect application of this formula, which is common among beginning students, is that they just 5 multiplied by this C and multiply by 90 because that's the final temperature. Or they use 5 times 4,002 times 25, which was the initial temperature. But of course, both are all incorrect. Another example, this iron block of mass 8 kg has a specific capacity of 450. A heater provides this 540,000 joules of energy to heat a block. What is the increase in temperature of the iron block? So again, this is another way to apply. So you can, this time around you want to find the increase. So just substitute in the values and find for the change in terms of the temperature of the iron block. And it should give you 150 degrees Celsius. Again, but please remember that the iron block changes its temperature by 150 degrees Celsius. It doesn't mean that its final temperature is 150. So the final temperature is not to 150 degrees Celsius. Example 3 is actually an extension. It's the same question, except that my question changed. I give you the initial temperature is 30 degrees, and what is the final temperature of the iron block? So from our previous question, we know that the increase in temperature is 150. So the final temperature, since it started out from 30, the final temperature will be 30 plus 150 equals to 180 degrees Celsius. So that's the final temperature of the block. Or alternatively, you can use this and you substitute in the same thing. And this time around, you can use the lower temperature of 30 degrees and put in here. And by solving this theta H, which is the final temperature, you should get 180, which of course is the same. Okay, before I go, this is a practice question for you. A cup of water of mass 500 grams with initial temperature of 80 degrees is left to cool down. It's found that it has lost a total of 100,000 joules of energy. What is the final temperature of water, given that specific capacity of water is 4,200? The answer is 32.4 degrees Celsius. If you didn't get it, look at the unit of mass of water. Most likely you made a mistake there. Okay, that's all for today's lesson. Thank you. Please subscribe and support my channel. For my other physics video lesson arranged according to topics, please visit my blog at boringphysicsteacherswordpress.com. You can subscribe to my channel to be informed when I upload new physics video lessons. Thank you.